Good day, sir. Today we will present our statistics assignment on multiple linear regression analysis. Multiple linear regression, or MLR, is a statistical technique used to examine the relationship between one dependent variable and multiple independent variables. The purpose of this study is to develop a multiple linear regression model to predict students' final examinations. For this study, we used a dataset from Kaggle titled Student Performance for Multiple Linear Regression. The dataset contains 1,615 student records and includes 5 variable names, which are course name, class number, study hours, last exam score, and exam score. The dataset provides information about student study habit score. In our regression model, the dependent variable represented by y. The independent variables are x1, study, which represents the average number of hours spent studying, x2, last exam score, x3, class number, which represents the class section assigned to the student. The variable course name was excluded because it is a categorical text variable, while multiple linear regression requires numerical variables. I will now pass the presentation to Purnasri.
Thank you, Kachini. Before developing the regression model, we analyzed the descriptive statistic of the data set. The average class number is 2.283 with a standard deviation of 1.195. Students study an average of 4.253 hours with study hours ranging from 0.5 to 9.8 hours. The mean previous examination score is 64.781 marks, while the mean final examination score is 59.781 marks. So we can see the relatively high standard deviation for the both examination score indicate that student performance will rise across the data set. So let's move on to the next slide. It shows the multiple linear regression equation as linear regression as exam score equals to 26.898 plus 0.508 in bracket class number plus 7.084 in bracket study hours plus 0.025 in bracket last exam based on the three independent variables. The regression coefficients show how much the predicted exam score changes when one independent variable increases by 1 unit while the other variables remain constant. Here it shows the model fit assessment. To evaluate the model's performance, we examine several regression statistics. The R-square value is 0.9804, which means that 98.04% of the variation in examination scores can be explained by the independent variables. While the multiple R value is 0.9902, indicating a very strong relationship between the predictors and examination scores. Standard error is 3.007, which indicates high prediction accuracy. Now I will pass this presentation to next person to continue.
Thank you, Purnasuri. So next is coefficient analysis. Next, we analyze the regression coefficients and their significance for class number. The coefficient is 0.508. This means that for every 1 unit increase in class number, the predicted examination score increases by approximately 0.508 marks. For study hours, the coefficient is 7.084. This means that each additional hour studies increases the predicted exam score by approximately 7.084 marks. For last exam score, the coefficient is 0.025, meaning that a 1 mark increase in a previous examination score increases the predicted score by approximately 0.025 marks. All variables have p-values less than 0.05, indicating that they are. So next slide is prediction using the model. We also use the regression model predict examination scores. For prediction 1, a student in class 2 studying 5 hours with a previous examination score 70 marks is predicted to achieve approximately 65.08 marks. For prediction 2, a student in class 4 studying 8 hours with previous examination score of 85 marks is predicted to achieve approximately 87.73 marks. This prediction demonstrates how the model can be used to estimate students' academic performance. In conclusion, this study successfully developed a multiple linear regression (MLR) model to predict students' examination scores. The model achieved an R-square value of 0.9804, meaning that 98.04% of the variation in examination score was explained by the selected independent variables. The ANOVA result confirmed that the overall model statistically significant and all predictors had p-value below 0.05. Among all variables, study hours was identified as the strongest predictor of examination performance. Therefore, students who spend more time studying are generally expected to achieve higher examination score, holding other factors constant. Thank you for your attention.